Hey folks, Russ Tyndall here with Blue Line CNC. Welcome to video number 4 of this series where I show you how we create a police flag. In this case, it's a Arizona Department of Public Safety flag, state trooper. In this video, we're going to go ahead and cut it on the CNC. If you watched the first 3 videos, you saw me design the flag in video number 1 using VCarve Pro, and in video number 2 we went into Adobe Illustrator, we created a graphic, and then in video number 3 we brought that graphic into the first video we created, into that design, and we integrated the two. So now we're going to put it all together and we're going to cut it on the CNC. I wanted to show you a few things first, and then we'll get started. First of all is, in fact, let me bring you up a little closer. This is how I begin all my flags. It's with a panel that's already cut to size. As you recall the dimensions, it's 28.5 inches in width and 15 inches in height. And it's nothing more than a panel which I've glued up. It's oak wood and it's pretty straightforward. I've gone ahead and stained it black on the surface and also on these edges lengthwise. I haven't done this edge for a specific reason, which you'll see later in the video. But yeah, it's pretty basic, pretty straightforward, and obviously nothing on the back side. And I wanted to show you how I go ahead and fixture it on the table and get it set up. If you notice, the spoil board itself has a whole bunch of holes in it. Well, that is set up for dogs, and I can move these dogs around depending on any particular project that I happen to be working on at that time. Right now it's set up to work on this flag itself, this flag. And as you can see, I've got these 2 dogs over here on the left and these 2 here on the bottom. So if we take our workpiece and we move it down to where it touches those dogs on the bottom, and then we slide it over on the left, you'll see they meet those surfaces. And I know when I use some lateral clamping at the top and over here on the right, I know that this position right here will be my offset in Mach 4. And if you recall, in VCarve Pro, we had our XY datum here in the center. Well, off camera, I moved that to the lower left and recalculated all my tool paths in VCarve Pro. So in order to provide the proper clamping, what I have is some walnut pieces of hardwood, and I place that in as a spacer. So any tooling operations that take place and anything with the dust collection will clear those clamps. And I just simply provide a little bit of pressure on the top while I clamp it down using my elbow and forearm. And then over here on the right side, I have some Craig clamps, 3 of them, and they also go in some dog holes that are set up. And I have 3 pieces of walnut, which I use over here. And if you can tell, they are not as high as the flag surface itself. So when I have my milling bits, which come past the surface of the flag, they won't cut into these spacers. And these spacers exist primarily to keep the bit away from these Craig clamps. I don't want to cut into that plastic and destroy my clamps. So we do a little turn on these Craig clamps, and we give them a little bit of lateral pressure so this flag is secure against these dogs. And yeah, that's basically it. So let's go ahead and take a look at the bits that we're going to use to carve this flag, and then we'll get started on the project. All right, so if you recall, in video number 3, we designated our tool paths. We designed our tool paths in VCarve Pro, and we established the bits that we were going to use, our milling bits. So our first one, if you remember, was it took a 1/2-inch collet, which is right here, and that was our RC1102 by Amana, and that was our V-bit right here. So it's a pretty hefty V-bit that we use for our union, and we'll cut out our stars with that. And if you remember, that's going to come over and hit that word Arizona in the upper right of the shoulder patch for the Arizona Highway Patrol. And then we had 2 bits that we used for our stripes. We had a 1/4 inch end mill, and then we had an 1/8 inch end mill, and that's those 2, and those both accept the 1/4 inch collet, which is shown right here. Then we also have our 60-degree V-bit that we're going to use in this design, and then we have a more angled 45-degree V-bit, and that bit is right there, and they also use the 1/4 inch collet. So that is a summary of the bits we're going to use on this project.
All right, guys, we're going to get started on this project. Firing up the machine. I've gone ahead and done a spindle warm-up already, and we're just going to go ahead and we're going to go up into our offsets, and we're going to select the proper offset for our project, which in this case is G55. We're using the G55 offset, and I'm going to go ahead and go to File Operations and throw the thumb drive in the computer which is holding this project, and I'm going to go ahead and load the proper G-code. There you can see the USB drive being inserted in the lower right. We'll use our Windows Explorer, and we will navigate to the appropriate file, in which this case it's blue line flag, Arizona Highway Patrol patch and badge. So we'll go ahead and open that file, and you can see the G-code being opened on the left window and an actual picture of the flag, which mirrors what we created in VCarve Pro in that right window, showing the patch and badge. And the window there where I'm hovering with my mouse now is just showing the file itself, the G-code file itself. It's showing the tool paths and the bits that are going to be used for each tool path. Beginning in the order that we specified, starting with that 90-degree V-bit. So what we're going to go ahead and do now is we have to zero out the Z-axis with that 90-degree V-bit. So we're going to go ahead and place it in the area where we're going to be working, and in this case, it's the union is in the upper left area of the flag itself. We're going to go to our touch plate operations, and we're going to zero that bit down and have it touch off right in that area where we're working. And there you can see the bit touched off to its proper Z height on the touch plate. Go ahead and remove the touch plate and put it back in its holder. Get it out of the way. And what I like to do is I always like to go to work XY0 before I run the operation. So I'll click on that, and I'll go ahead and bring the bit back to its XY location, which in our case is that G55 offset, that lower left-hand corner. And then we'll just go ahead and we'll hit cycle start on our Mach 4 on our machine. And you usually have to hit it twice in the beginning to get it to go. So the machine will fire up, and it will move and start to carve the stars of the union that we specified. And it will actually carve them in the order that we specified. Normally I would run this operation with dust collection. I'm not running this flag at all with dust collection. I want you to be able to see what's happening in the video itself. But my dust collection is pretty effective, and it does a superb job of picking up all the chips. There is virtually nothing left on my table during these operations. And I'll put a link in the channel down in the description below to where you can obtain the dust collection shoe that I'm using if you're so interested. So rather than have you watch this whole video at regular speed, this would take a long time. I've sped up portions of it. As you can tell, we're zipping through these stars pretty quickly here. I think we're at 600 speed, 600% rather. So we'll just run through this tool path and we'll move on to the next. It's just systematically carving those stars out. And here in a second, you're going to see it go over to the right side of the flag in the upper right. As you recall, we've included the word Arizona of the Department of Public Safety patch in this toolpath. And there it is. It's gone over, and now it's carving those letters out, that word Arizona. And when it's done with that, it just comes back over and hits the stars again where it left off to finish out this toolpath. So once a toolpath has run, what's really neat about Mach 4, and I'm sure Mach 3 did this as well, I don't know, I've never used Mach 3, it will stop. When this specific toolpath is run, the bit will stop spinning in the spindle, and on Mach, you'll see here in a second, when it stops, it tells you to go ahead and change your tool. It's telling us to change it to a 46054K, which is our downcut spiral 1/4 inch. So what we're going to go ahead and do is click on Go to Manual Tool Change Location, MTC location, and you'll see when we do that, the spindle raises up and it goes to our predetermined location where we change our tools. And I've gone ahead and done that in the setup of my Mach. It's always the same. This is my manual tool change location, center of the machine in the front. In here, I'm just using the collet wrenches, and I am just taking out that 90-degree V-bit, holding it with my thumb so it doesn't drop out and hit the spoil board or the material itself. Sometimes those bits will drop, so you have to be careful when you remove them. Then I'm just going to unscrew the collet and screw the 1/4 inch collet on and insert the 1/4 inch downcut milling bit and mill. We'll just tighten it up with our ER32 collet wrenches. And we'll call it good for that. And then we'll bring our touch-off plate back on the material. We'll clean it off real good so there's no sawdust. It's important to have a clean surface when you use that touch-off plate. One little speck of sawdust could throw the Z0 positioning off, so absolutely make sure you're clean. I like to use an airline and blow all the sawdust off before I place that touch plate down. Then I lower the bit down and we'll go ahead and attach that magnet, and we'll do a zeroing procedure like we did when we placed the 90-degree V-bit in. Here I am attaching the magnet. We'll go back into Mach. We use the Auto Z touch plate button, and we'll press that center button. Get the reminder that's telling us to make sure your magnet's on there. We'll click on it, and that bit will lower and zero accordingly. We'll go ahead and take it off the project board and secure it. And again, we'll move that bit to the XYZ, the home, go to XYZ home. So the bit will move over to its lower left, and then we'll hit cycle start once again. Here I'm just lowering the feed rate of this toolpath down to 75%. I didn't want to run this particular toolpath at 100%. It's pretty hot and it goes pretty quick, and I want to be a little conservative with my bits, so I'm taking this one a little bit slower. It probably could easily handle at full 100% feed rate, but here you can see in the video it's going at 75%. This is not a stepped up speed rate in editing. This is the actual feed rate. It is pretty quick. So if I had done it at 100% feed rate, it would be moving along and sailing along a lot faster. So I slow it down just a little bit. Here in a second, you're going to see me speed this up. Again, I'm not going to have you sit through the carving of all these stripes. This video would be 2 hours long, and we don't need to do that. I'm not going to show any more of the Mach 4 procedures. That would be repetitive to do that at this point, but it's the same throughout the remainder of the project. We'll get the notices to go ahead and the machine will stop after each tool path. It'll tell us to change it to the next tool. We'll go ahead and do new touch-off procedures for each bit and continue on with the next. So you won't see any more of the Mach 4 procedures in this video. We'll just stick with the carving of it. You can see all that sawdust collecting in the foreground of the image. If I had the dust collection running, or it's running, but if I had the shoe on, none of that sawdust would be there. It would be extremely clean. And again, we'll just go through a bit change and swap that 1/4 inch end mill out for the 1/8 inch downcut end mill. As you recall, that was the 3rd bit in our order of operations. Here we are, just going ahead and cleaning off that surface once again. I'm using an airline to make sure there's no sawdust whatsoever in the area where I'm going to place that touch-off plate. And we'll go ahead and bring the spindle over, and we'll lower that 1/8 inch end mill down over the plate itself, get it positioned where we want it. And place it in the area as best as we possibly can where we touched our 1/4 inch end mill off. We want to be as accurate as possible with this file as well, or with this tool. I use a game controller, an Xbox 360 game controller, to control my spindle movement. I find that to be really useful, and it works a lot better for my workflow than to use the keyboard of the computer. It's got about a 10-foot cord on it, so I can walk around the project and look at what I'm doing with that spindle as I'm moving it, and it really works out good. The control software for that Xbox 360 controller is a program called Antimicro, A-N-T-I-M-I-C-R-O. If you do an internet search for it, you'll find it out there. It's free of charge, and I think it's just like a macro controller is what it's called. It just creates, and you can create your own macros or combinations of keystrokes and assign them to the buttons of the game controller. Works really good. And if you were paying attention here, you saw that 1/8 inch end mill get in really tight where the 1/4 inch end mill could not. So it really cleans out those tool paths nice. We're going to go ahead and put in our 45-degree VCarve bit. And as you recall, this carves some of the detail in the badge itself, the seal of the state of Arizona. gets carved out with this 45-degree VCarve or V-bit. So we're going to go ahead and place that touch-off plate in that exact area where we're going to be carving this detail out. In this case, it is that star. So we'll just do another touch-off procedure. Get that bit lowered down to that area where we're going to be at, and we'll attach the magnet. And run that touch-off procedure itself in Mach 4. It'll come over and start its carve. And again, I'll go ahead and speed this up so you don't have to watch this whole tool path run at regular speed. And there you go. Carves it out real nice. I find that the 45-degree V-bit works really well for this finer detail. And after this tool path is complete, we'll move on to our last tool path of the project, which, if you recall, was a 60-degree V-bit. So we'll go ahead and remove the 45-degree V-bit, insert the 60-degree V-bit, and perform another touch-off procedure. And I will place that touch-off plate kind of in the general area of both the badge and the patch. And I think I use here, I'm going to use the lower area of that patch, that shoulder patch. And I'll place the touch-off plate in that location. And that'll be representative of a good Z0 height for both the badge and the patch. I don't think we'll get too much variation in material between the two. Thickness variation, that is. That's the reasoning for placing the touch-off plate in these locations. There could be a slight variation in the thickness of your material from one side of the flag to the other. So you always want to make sure that you are zeroing out your Z-axis in the area that you're going to be carving. Again, we'll just zip through the carve so you don't have to sit here and watch this whole tool path being run. Just enjoy the music. I hope you're enjoying the music selection that I've selected for this video. Try to make it as easy listening as possible, but enjoyable to everybody. Guys, again, I can't ask you enough, if you are enjoying the content that I create on YouTube and you're learning something from these videos, and even if it's just slightly interesting to you, I would love it if you would go ahead and subscribe to my channel and go ahead and hit the like button. That really helps me out with my YouTube metrics and grows my membership base and my viewership, so to speak. So again, please consider subscribing if you like what you see. I can't thank you enough in advance for you doing that. And it's my objective to push out as much content as possible. Don't forget to hit that bell icon too to be notified when that new content does get pushed out. It's not as often as I would like it, but I do make a faithful attempt at getting that out there as frequently as I can. So here we go. I'm just doing an overall of the flag at this point, at this stage of the game. So now what I've done is the flag itself is completely off the CNC, and it's time to finish the edges. And here's the reason why we didn't merely put stain on the edges of this surface when we were staining the lengthwise edges. Is the stain will weep into the grain, and if we did that where the white stripes are here, where the carved out stripes are, you would see that that stain being weeped up those end grains. So in order to avoid that, we go ahead and mask the white stripes off, and we stain only the black areas, as I'm doing right now. And that leaves the white stripes totally clean. Just make sure you wipe the stain off so it doesn't sit there on the ends. We'll go ahead and remove the tape after we've stained it. It really doesn't take that long to dry, especially on this end grain. It sucks up really, really quickly. You know, maybe 5 or 10 minutes, and you can go ahead and pull that tape off like I'm doing. And it reveals a really nice finished edge. And I think it makes the flag more complete looking. So the next thing that I do is go ahead and mask off the area where that blue line is going to be. So very carefully, I'm just laying down some painter's tape and securing it along the edge so we don't get any overflow of the blue stain into the black area. Once we get our stripe masked off, I'll use some craft paper and go ahead and secure it down to the flag just to avoid any potential mistakes that could happen. I've had some close calls in the past, and I have been very thankful that this paper has been placed down. Little drips and whatnot that the paper has caught and saved the project. And then I go ahead and stain the stripes out. In this case, it's a Minwax, another Minwax based product. The black color that I use, I believe, is charcoal, or no, it's pure black. It's Minwax water-based stain. This is a navy blue, if I'm not mistaken. Like to use these foam brushes. They work really well for this purpose. I'm going to go ahead and hit that end grain as well so that blue color wraps around the edges of the flag. Get a nice even coat. Then we'll go ahead and let it dry for several hours, and we'll come back with 220 grit sandpaper like you see me doing right there. And we're just going to knock off that raised grain. Whenever you get wood wet and dry it, the grain will raise. So I like to do this stripe in 2 coats. So after that sawdust has been removed from the sanding, I'll go ahead and hit it again with a 2nd coat of blue stain and let it dry thoroughly. Then once that's complete, I have a little dental pick that I use to pick up the edges of the tape and remove the tape from the project. A little weeping, or I think it's called a weeping tool, or weeding tool, excuse me. You can get it at any craft store like, oh gosh, I think like Michael's and whatnot. They all have them wherever you can get like a Cricut machine or Silhouette machine. Those little weeding tools used for removing material is really useful for removing the tape. Then what I'll do is bring the flag over on the other CNC that I have that's set up with laser operations. This is a JTech 4.2 watt laser mounted on an Axiom machine. This is the machine that I began carving my flags out on and doing a lot of other CNC projects. It's still a great machine. I haven't got rid of it yet, and I don't plan on it. It's planning on staying right next to my AVID. And I do use it for a lot of other projects and tooling operations. So here we are. We're just going ahead and putting a little branding on the back of the flag. Why not, right? And then I'll go ahead and hit the back side with an orbital, random orbital sander and just get the stain off the edges as best as I can. And then we'll go ahead and place the flag inside the spray booth and hit it with a little semi-gloss lacquer. I'm using Deft brand semi-gloss. I find that I get good results with that brand. There's a lot of others out there that work as equally well. Then we'll attach some hardware on the back so it can hang. And here you go, my friends. This is the final product. This is how it turned out. I think it turned out spectacular. Again, if you like this content, please don't forget to hit the like button and subscribe to the channel. And I really appreciate you coming along for the ride. Thanks, guys.